Okay, hi everybody. Today is Wednesday, 16th of September, and this is the community meeting for Metal3. We usually start with an introduction round, so if there's anybody in the call who has not yet participated and wants to say hi or introduce themselves, please do so. I'm going to pause now for a couple of seconds. So take this opportunity if you wish. Okay, then let's dive in. Maybe the first point would be a short PSA to say that the CNCF talk has accepted Metal3 as a sandbox project. So congratulations everybody on this great achievement. And let's take this project even further as part of the CNCF now.
Thanks.
Okay, then Doug, I guess up to you.
Thanks, Mal. I guess we've been working on this a couple of months now. I brought up the idea of reworking the bare metal operator with a newer version of KubeBuilder to allow us to eventually drop what we have now as an incompatible API where we have a floating point value in our API. It will also allow us to bring in some features like webhooks and some other things that we've been sort of wanting to have but not able to have given the version of the operator SDK that we're using. So I've written up a plan to do that migration, and I was looking for some sort of agreement about when we could say the plan is far enough along that I could go ahead with it. I have a window of time within the next couple of weeks where I can do the work, and I don't know when I'll have it again. So I'd like to get that done soon if we can. There were a few comments on the latest draft, and I think I have not updated the draft, but if you assume that all of those comments will be accepted and read them as part of the draft, then I'd like to get an agreement on that version of the document.
Yeah, I think there was already kind of a consensus on that, right? Like there was not too much activity lately. But maybe we can put a formal date, let's say, for the consensus.
Yeah, I proposed the 23rd, which I think is next Wednesday or Tuesday. I forget. Wednesday. So a week from today. And I wanted to go ahead and get the document merged before I committed to doing a bunch of the work, because like your suggestion about forking KubeBuilder instead of vendoring it, that would have been a big change in the process. So I'm glad that we had that part of the conversation before I started the work.
Did you make a decision by the way regarding this? Like, are you going to try to use this fork approach or vendor it?
Yeah, I'll try to use the fork. I'm not sure what that's going to do to our build processes. I need to figure out exactly how to specify to install a version of KubeBuilder from a fork like that in a particular directory instead of overriding something that the user might have themselves, because we do have to change the version of, and it's not actually KubeBuilder, it's controller gen, I think. But we do have to change the code in order to have the floating point value supported, I think. And so it was really straightforward for me to see how to build Go code in the repository and put the binary in a particular place. It was less obvious how I could do that from an arbitrary Git repo and have the binary not end up in the Go path. And that's just, you know, lack of Go skills on my part. So there's probably a way to do it. I just don't know off the top of my head.
Yeah. I think if you were to do that in the tools folder or hack tools or like wherever, like put a Go mod there that replaces the actual KubeBuilder by the fork, then you would be able to do like a go get and then like build the binaries in that specific folder from that specific fork. And
okay,
then
cool.
it's just a matter of putting instead of just putting like control gen, just like putting the link, like putting the exact path to this executable that was built to not use whatever is on the machine of the developer, but use the one that we just built.
Right. Okay. Yeah, it was the having the Go mod without the vendored code was the not obvious part to me, but I get what you're saying now about just using a replacement. Yeah.
I mean, we're not doing it this way exactly in CapM3. In CapM3, we just download the already compiled executable, but for some of them, like there are some things that we compile in the tools folder.
Okay.
So maybe like there's something that can be reused. I don't know, like in this process.
Yeah, I'll
anyways,
look at that as an example. Yeah.
Yeah, feel free to ping
Okay.
ping us if there's any question related to this. But yeah, really looking forward to have like Metal operator move to KubeBuilder.
Yeah, I think the consistency will improve our developer experience all around. So.
Okay, are there any like questions or comments related to this topic? No? Okay, cool. Let's move on then. The next topic is mine. It's just more like a disclaimer kind of thing, saying that we are now working on putting TLS setup for Ironic. I listed all the PRs here. Normally, looks like no, okay, there's the link. So for each of them, you can see. So we are modifying all like the containers, bare metal operator itself also, and then the deployment method for cluster.ctl, so that we deploy BMO with the CA certificate that we expect, and also like of course the Metal3 event is modified so that everything is deployed with TLS. So please have a look. We are really looking for reviews, especially on the Ironic images. That's where it tends to be a bit like slow to get in. And so yeah, like take a look, review please, and let us know if there's anything that needs to be modified. And oh, by the way, an update related to the same topic. Like we were at first aiming at having an MTLS setup, right? Like we wanted to have client authenticated, but we're hitting a roadblocker there. Like the Ironic needs to expose part of its API without authentication, because IPA, if you want to have client certificates in IPA, you need to build a specific image. And we don't really want to do that for every single deployment. So we need to have part of the API that would be without MTLS, so without client authentication, and part of it that would be with authentication. So we tried to do that, and it's possible to do it in HTTPD or Apache. We could put the setup together, but then the problem came from BMO, or let's say from Go, because in order to have part of the things with client authentication and part without, Apache uses a feature called post-handshake authentication, and this is not supported in Go. So we were not able to do the MTLS setup due to this, and now we are like looking how we could go around this problem to have the MTLS properly set up, but it looks complicated. So we are postponing like the MTLS implementation for a bit. Meanwhile, you have the basic authentication that was implemented already in Ironic, plus the TLS to not have the password going like unencrypted. Going in, so to not have them going in plain text between BMO and Ironic, or Ironic and Inspector. So, is there any question or comments related to this?
Hi, Mel. So going forward, this will be the mandatory thing or the only option, or the fallback is also supported?
No, there's nothing like mandatory, right? Like, for example, in Metal3 event, we have introduced Ironic TLS setup variable that if you put it to false, then of course you will not be using TLS. So, well, or rather in that case, opt out, because by default it's like set to deploy with TLS. But of course, you can disable.
Yeah, okay, thank you.
However, we highly recommend to enable TLS, because otherwise, like you have your like credentials that go in plain text between your different pods, and that could be like between different nodes, etc. So it's a bit more risky, let's say.
Right.
Can we give demos sometime whenever possible?
Sure, actually, we can do it next meeting probably. There's nothing much to see, right? Like it's just the different like the certificates are mounted from a secret in the containers and the proper variable set. So it's not an impressive demo, but of course I can show it next meeting.
Sure. Okay, thank you.
Yeah, no problem. Then Ferus, you want to take the next topic?
Yeah, hi. I just wanted to bring this topic again related to Metal3 book. We have discussed a couple of times about this, that we need some book, and then we have a couple of repositories in the Metal3, each having its own documentation, and sometimes it's a bit difficult for newcomers or the end users to use this. So basically, we're lacking some kind of the book that would be much more easier for the user. And then especially now when we're the CNCF project, I think it would be wise to have a common place for the documentation, because for example, we have the website, we have API definitions in each repository, but still it's a bit complicated and confusing. So we were discussing it a bit internally with Smile to start some kind of book. For example, the first thing that came into my mind was this MD book that is also used, for example, by the cluster API, if you have seen it. It's basically based on the Markdown. So we basically need to put the references in the structure of the book, and then that will just basically show up whatever you have in the Markdown. The problem is that in the Metal3 we have, for example, BMO and CapM3 and Ironic, as I said, like different repositories. And in the MD book, it's a bit problematic to fetch the documentations from each repository and then present it. So one thing that I was thinking is that we could put all the documentations in a single place, for example, under the Metal3 docs or any other repository. But that has some problem. For example, when there is some change in the API, for example, in the BMO, we usually put the documentation in the BMO, but not in the Metal3 docs. Or if it's design, yes, that can be changed, but it might be a bit problematic. Another way is that we keep the documentation under each repository. For example, CapM3 its own, BMO its own, but then we use these GitSub modules under the Metal3 docs, for example, that will fetch the documentation from each repository, and then from there we create the book, for example. But this is, as I said, like just one way to do that, and I just wanted to bring it and hear more. Maybe there are some other ways, like alternatives to do that. And actually, I have started like writing this with empty book, and I can maybe just quickly show you how it looks like, because it's pretty much like very simple to do, because you just put the references. So maybe can I share the screen, Mile?
Sure. Let me stop sharing.
Yeah, thanks. So basically, you can see that it's exactly the same as in the cluster API, because cluster API is also using under the hood the same empty book or the Rust. So we could have, for example, different sections like a developer guide or the user guide, some references, and then, for example, in developer guide, we could explain, like all the objects, like the custom resources that we have. And you can see whatever is written here, it's actually documentations are coming from the documentations that we have in each repository. For example, this is from the from the BMO, and I'm just putting the reference. So it's very easy to do that, and I think it will we will need some refactoring in the existing documentations, because whatever we have already, like we have a single doc that explains a lot of stuff in one documentation. But if we're going with these kind of books, then we'll have to split documentation into smaller chunks and then put the references in here, for example. But yeah, but as I said, like this is one option, like, and I wanted to hear like if there is any other options that you're saying would be better instead of using the MZ book, or like any other suggestions.
Yeah, well, I can start already with a comment. Well, let's say like I played a bit with the idea since we talked about it, and I was thinking maybe like we could have actually the generation of each, like let's say if each project is a chapter of the book, then we could generate those independently, so that we keep the documentation with the code, and the chapter, like let's say when we update something, for example in CapM3, we do a PR. When the PR is merged, we would rebuild the rebuild this specific chapter, meaning that we will need to have them hosted in different like websites, but we could have from Metal3 docs kind of a table of content that covers them all, so that whenever there's a change in one of the repo, then it automatically rebuild that specific part of the book, and then we just have this kind of like binder that makes the link between the different projects in Metal3 docs.
Yeah, that's also a good idea actually. So we will have, for example, 3 different URLs, but all of them will be kind of mentioned in a single place that you can jump into from one to another.
Yeah, exactly. We would have this kind of high-level entry point, let's say, like for the book, and then the left side could, like, we could have this kind of frame where we have each of the project like being shown, but then on the left, like the table of content would still be coming from the Metal3 docs one, allowing you to very easily switch between the different parts of the book.
Yep.
And a great thing for this is that because now we are part of the CNCF project, CNCF, we have access to their resources, and that includes Netlify accounts. So we can put this whole like generation and hosting of the book completely automated with Netlify. We don't need to have our own building process, let's say, and hosting.
Yeah, this is even better.
But I have to say this kind of a book is really welcomed because like Ferus, you said that for the newcomers this is the easiest way to get into the project, and I really support the idea of having such a book like they have in Cube Builder and Cluster API. This is definitely something that we need.
Yeah, one comment. I also agree it's a great idea and a great initiative. Comment/question is, I understand the point of keeping the different sections each on their own repo, but I think this has pros and cons in the sense that it might be harder to keep everything in one place, and especially for new contributors. But let's say I'm new to Metal3 and I see a problem in the book and the documentation. I want to fix it. It's harder to find. That might seem like a simple logistics thing, but I'm also thinking, Mile, you were saying that the content is different depending on the repo, but also the content should maybe be different depending on the audience. So it's not the same type of documentation for end users and for developers. And in that sense, I think it could be just thinking aloud, right? So it's food for thought, but maybe it could be better to have like a single location for one type of documentation, which is like more end user oriented, and maybe keep the more developer oriented specific to a component, let's say the PMO API details in the PMO repo or something like that. Do you see what I mean?
Yeah, definitely, and that's a very, very good point. But then Fellows also had raised the issue that if it's decoupled from the code, there's higher risk that the documentation will become out of date with what is actually in the code. So I don't know what's your take on this.
Yeah, I see. I mentioned I see pros and cons. So on the other hand, if each repo maintains their own set of documentation, there's also the risk of inconsistencies in terms of the documentation of that repo looks in one looks different from the other. One chapter looks different to the other. I don't know how bad that is, but I mean maybe. Looking at the cluster API book, just took a quick look now at the source, but they seem to have everything in one place, right?
Yes,
but at the same time, they. Oh, sorry. Go on, Feroz.
Yeah, sorry. They keep everything in a single place because the repository itself is one repo.
Okay. Yeah. Fair enough. Yeah.
Can we not keep like end user plus the developer bits within the repo itself, and then with have for different for end user and developers separate sections within the book that imports the corresponding part of the from the respective repositories?
Yeah, that is definitely an option. I think maybe we would need to have maybe a small proof of concept kind of book so that we would be able to see how that would go.
Yeah, sure. I can try to do a POC kind of thing, trying to use all the different options that are mentioned right now.
Sure. And Doug has a. Oh, sorry.
Yeah.
Sorry, Doug.
Yeah, it seems like we're trying to decide between maintaining a more complicated build system for a distributed set of content, or maintaining a simpler build system but having the overhead of having to ensure that we keep the documentation up to date when we make code changes. And I don't know about you, but maintaining complicated build systems is not really high on my list of favorite things to do. So I'm leaning towards just putting all of the content in one place to keep everything simple for contributors and for the maintainers. And if that means that once in a while, in order to complete a task, you have to do 2 pull requests instead of 1, I feel like I can sign up for that.
Sure. It also means that we have to be a bit more strict verifying whenever a PR comes in that if there is any documentation change, that it's actually has a counterpart PR in the documentation. So we also need to be a bit more careful in the review process.
Yeah, that's a good point. I don't know. I mean, who is the audience for this book? That Pep brought up the audience. Like, how much of the API, what other kinds of changes would we expect to require documentation updates of the sort that would go into this particular book?
Yeah, I was thinking more that it's more oriented for the developers. So I'm expecting, I'm expecting that it's not gonna be changed quite often, unless there is a new object or a new API or something that is really important to be mentioned in the documentation. So in that sense, I think if we just keep everything in a single place, then it would be much easier.
Okay. Yeah, I think I want to change my answer then. If it's developer documentation, then I think it should probably live closer to the code, because that is the sort of thing where small changes would need to be reflected quite often. But if it's if it's end user documentation, then I feel like there can be a little bit of a lag, or there'd be lots of changes where there wouldn't need to be doc updates. So I guess
we could maybe sorry.
Sorry, go ahead.
We could maybe take an approach that is similar to CAPI, where they have a bit of an hybrid thing, with the first part of the book being really oriented towards end user, while the second half is really more for developer and explaining like how to set up the development environment, like how to build a provider, etc. And so in that case, like it's clear in the book which is for what, basically. So we could also have a similar approach where we have the first part where we explain how to deploy and how to use the different components of Metal3, and then the second part that goes more into like the concepts of the API and everything that is like tied to the repo itself.
Yeah, I like that. And even quite a bit of the setup work for setting up a development environment could be in one place. But if we start getting into things like API changes and documenting all of the APIs, then I feel like that's going to be harder to keep up to date correctly in a central place. Unless we had some sort of automation around that pulled in CRD definitions and generated files or something. But again, we're getting into complicated build systems. So.
Yeah, actually, for the APIs themselves, if we want documentation on the APIs themselves, we can just refer to GoDoc. Like put links in the book that will take you directly to the correct GoDoc page that explains the API of the object you're working with.
Yeah, that makes sense.
Yeah. It's anyway something I think that needs a bit more like thinking around, trying different solutions, different ways to do, and maybe we can raise the discussion again in 1 or 2 meetings, Feroz.
Sure. I also try to think about it more, like, yeah. But thanks a lot for the comments.
Is there any further like comments or question on that topic?
Just a brief one that, we already have this type of double PR type of approach in the more user-facing documentation in the Metal3 dev and the try it page. So they live in different repos, and we often see PRs, matching PRs. And I'm just mentioning this because it's something that we already kind of suffer to some extent, or experience. And yeah, maybe that hybrid approach sounds like a good idea, like keep more developer-oriented documentation close to the source and closer to the source, and end-user documentation more on a dedicated repo, maybe. But yeah, I agree. Let's continue thinking about it. Good initiative.
It's actually great that you brought this up with this try it, because we've actually already seen a couple of times that it went out of sync with the actual Metal3 dev env, and like following the instructions there was not like didn't bring you like to a successful web environment.
Yeah, maybe if we're going to switch to this new tool, that's an opportunity to create a try it book in the Metal3 dev env repo. And the try it page can have some basic information and then link over there to the details.
Definitely. Okay, well then if there's no further question or comment, then Arvinder, the floor is yours.
I hope you can hear me.
Yes.
Okay, great, thank you. So I had a proposal. I linked it in the document. Wanted to ask people to go take a look. I know Mail has already left some comments on that, but it would be great if other folks could take a look. I can provide a very quick summary of what the proposal is, what the motivation there is. Just take a few minutes if you don't mind. So I work for AT&T. We use Metal3 quite a bit for our Kubernetes clusters. And one of the requirements that we had was that we do commonly need to make changes, host configuration changes on the nodes that have already been deployed. These changes are things like mostly sysadmin tasks, like adding IP table rules. Let's say you wanted to poke a hole in your firewall, or you wanted to run a sysctl command to manipulate some host settings. Could also be other maintenance tasks. It could also be software updates. Let's say you wanted to update the software packages to a newer version because of a security vulnerability that's been detected. So various tasks that need to be done on a host, and you can, in this particular case, I call them in-place operations, executors, primarily things that just require changes that don't require any reboot, that definitely don't require a re-provisioning of the host. And so as you can imagine, something like this is very useful for people like us who build out very large clusters. For example, a typical scenario might be that we have a 50-node cluster and we want to roll out changes, a certain small change to all 50 nodes. It's not possible today. If you look at the cluster API from Metal3 model, it's driven entirely by the ability to destroy a machine or recreate a new one. These small changes are not really possible today. So that's the primary motivation for the proposal, is to have a feature like that incorporated. The proposal consists of two parts. If I can just go over them real quick here. One is that there's something called what I call an in-place executor. This is just a piece of program that anyone can write. I gave a couple of examples of an Ansible operator, very useful tool that can work with this large ecosystem of Ansible modules that can do things like add firewall rules, all kinds of other things that you can do with Ansible modules. Developers might write their own in-place executors that, for example, would do software updates for a particular OS that they're using. And there could be other examples that people come up with, but those are two common scenarios that we often deal with. So that's what I call an in-place executor. And as you can imagine, there has to be certain input to this executor that actually tells it to do something. And that's what's actually being shown there on the screen there. In that particular example is that you have, for example, the in-place executor Ansible operator, and you're actually passing in the configuration that it needs to perform the certain tasks that the user wants it to do. So that's one aspect of it, are these executors and the inputs they require. And the other aspect of the proposal is how do we sort of bring this into the cluster API and the CAP-M3 model. And here, there's obviously room for debate and discussion, but the proposal goes over one particular approach. And a lot of this information might be common knowledge to you guys, but I'll quickly go over it. In cluster API, you have this notion of a machine template. A machine template is entirely infra-provided provider object. So for example, with Metal3, we have something called a Metal3 machine template. AWS will have their own machine template. And when you say something like, hey, I want to create a machine deployment with 50 nodes, it's going to be my worker nodes. I want those 50 nodes to be based off of this template. And that machine template really becomes sort of the reference point off of which all these 50 machines are created from. It used to be the case that machine templates were immutable in cluster API, but more recently they've relaxed that assumption. So now what's possible today, and this kind of came out of a requirement from the AWS people, where they had certain metadata that they wanted to include in the machine template. And they wanted the user to be able to modify that metadata on the fly. But this was just metadata. It didn't require a complete reprovisioning of the machines, for example. And they just wanted that field to be mutable. So an exception was made that all machine templates can be mutable as long as it's the field that's changed is of no concern to Cluster API. Is handled entirely by the infrastructure provider itself. So this kind of lends itself to this idea of creating a new field or a new CR within our Metal3 machine template, which basically contains all the inputs to these in-place executors. So imagine going back to that scenario I described earlier, that if I had I had a machine deployment with 50 worker nodes, and I wanted to, tweak a firewall rule or something. As a user, it would be very clean and convenient for me to simply go and do a kubectl patch on a top-level object at the machine template level, and have that change be propagated down to all 50 nodes, where the executors that are running in the workload cluster can now actually go ahead and actually take that change and implement it on the nodes themselves. And that's kind of where this proposal goes, is it tries to sort of bring together in-place executors and cluster API in sort of a homogeneous way and provides a good user experience. So that in a nutshell is pretty much what the proposal is. If people can take a look, in particular, how the proposal actually is proposing implementing this logic. It requires some minimal changes in CAP-M3 at this point. But yeah, if people could take a look, I'd be more than happy to answer any questions anyone may have as well.
Could you just explain what part of this is bare metal specific?
Well, it's bare metal specific in the sense that, there's nothing here that's tied to Metal3 in particular, right? So you could take this approach and you could apply it to an AWS provider or to GCP, for example. You could certainly do that. What makes it, why we're proposing it for Metal3 is that, well, we're consumers of Metal3. I think as people who actually use bare metal clusters and actually deploy Kubernetes on our bare metal clusters, this is a common occurrence, right? This requirement for in-place changes. Maybe it's less so for the cloud providers. But I don't know if I answered your question or not. But it is kind of agnostic, right? You could take this idea and apply it to the AWS provider as well, or anyone else.
You said in your comment somewhere that you would bring that up also in CAPI, right?
Yeah, so I will bring this up. So in-place changes has come up quite a bit in Cluster API over the past year or so. The general sentiment, and this came up in the last meeting as well, the general sentiment is that this is something the infrastructure providers that want to support this should implement. And if you look at this machine template model, the machine template is entirely up to the infrastructure provider. Cluster API uses it, but those details are entirely provider specific. So I think from their standpoint, this is something that providers that want this feature can find clever ways to go ahead and implement it.
But couldn't it be also like implemented at the machine deployment level or KCP, so that it's not actually tied to the provider at all?
It could, but it has to fit into the Cluster API model of things, right? I think one way to think about it is that this is clearly something that should be part of machine template, because just like a machine template describes what an instance should look like, in-place executor template describes what an instance should look like in time, right, at the current moment, versus during the provisioning phase. I suspect the general bias is going to be to keep this as part of the machine template. But again, I'll obviously I'll throw this proposal their way as well and see what kind of input we get from them. But I feel like this is a machine deployment is a first-class citizen, and to ask them to have a similar object, a similar CR that is for in-place executors might be a tough sell. But definitely, I'll propose this to them as well. I'll pass it their way.
Okay, thanks.
So I will read your proposal because I have not read it yet. But my first reaction is that this is stuff that can be handled by an operator looking for nodes with particular labels and doing its thing, and it doesn't need to be tied into a specific provider anyway. And certainly if like CAPM3 is missing ways to like label machines or nodes or whatever in helpful ways, I mean, that's something we could definitely look into. But without having read this yet, I'm not clear on why we would want to make this something cloud specific when it's doing kind of generic stuff that an operator could do on any cluster.
Yeah, that's a good point. I mean, you could go entirely off on the side and not even think of it, your cluster, as it's something having been created via cluster API or via CAPM3. You could do a completely one-off side approach. But one of the motivations here really was try to fit this into the model of cluster API. In particular, like the example that I gave from a user experience standpoint, you already have the notion of a machine template today, which describes what a machine should look like during the provisioning phase. This is an extension of that. And as a user, it would be and not only that, but if you look at cluster API as this machine deployment model or the KCP model, it provides you this natural grouping of machines. So, like the example of 50 worker nodes, I have a machine deployment for that, and I want to make a particular change to those nodes. Like at least for me, logically, it would be a lot easier to simply do a kubectl patch on the template being used for those 50 nodes, and voila, those changes get carried out. Definitely, you could go ahead and create your own operator on the side. You could create your own CRDs. You can find a clever way to label the various Kubernetes nodes and find some means to link all that together. But this natural grouping of machines together and this usage of machine templates is nice, in my opinion. It's a very clean interface. Yeah.
Would you mind maybe like adding something in this proposal to talk about the because this approach is not like descriptive. I mean, it's you give the actions that you want to have applied on the node, right? You don't give the state that you want to reach. So how would you reconcile like that if after a node reboots that the executor doesn't run again or something like this on these annotations that might still be there on the node, or if a node is away for some time, like if it doesn't make sense anymore to run those commands, like is there a way to prevent it to be run on that node, or like basically how you counter the fact that it's not the state, the desired state that you're giving, but just the command that you're trying to run.
Yeah, those are good points. I have not considered all of the corner cases like that. Definitely not in this proposal. But yeah, you're right. I mean, you might have corner cases where a node might go down, it might reboot. Again, not to delve too much into the details of the proposal, but the idea being proposed is that you have an annotation on a node, and you have one or more executors that are looking at the node object in Kubernetes in the API server, and they're capable of reading this annotation and carrying out the task, the change required. Things might go wrong along the way. Yeah, the node might reboot. Something might happen. We'd have to consider those corner cases. I can't say that I've thought through all of those particular scenarios.
But if you could just add a section, like it doesn't have to be like fully thought through, like right, we can discuss it on the proposal, as long as you can, if you can just at least put the placeholder for that.
Sure. Yeah.
And Doug, you have comment?
Yeah, your comment about making the API be state-based rather than execution-based reminded me that OpenShift has an operator called a machine config operator that does something that sounds very similar to the goal behind this. So I wonder if you've looked at that at all. I mean, it's part of OpenShift, but it's open source, and I wouldn't expect it to be too tied up in the whole distribution. So it may be repurposable.
I did look at that a long time ago, not in the context of this particular work. I'm sure it is very similar. It also allows you to, like you said, make modification to the machine. I can reference that project in this proposal, but here, like I would say, what's being proposed is, like I mentioned, there's two aspects to it, right? You want to have support a flexible model which supports various executors that people may write over time, not just a particular executor. And the second thing is you want to somehow tie this into the current cluster API model of things. And that's what this proposal tries to do. And I don't think the machine config operator is CAPI specific, or I'm not sure if it's also general enough that it can support any kind of executor. But I can definitely reference that in here if there is something related in there.
Yeah, it's very much more focused on putting configuration on the operating system and not executing commands particularly. So, and the benefit of that is exactly that state management that Mail brought up. Like, if I'm looking at this Metal3 in-place executors template, you know, if I add a label to that resource, then the controller is going to go run all of those commands on every host again, right? And that isn't necessarily what you would have expected. But if you add a label to a machine config and the config values haven't changed, then the host doesn't change, right? So it's I think focusing on having a tool that lets you run arbitrary commands on a bunch of hosts is going to end up giving you a system where you're running lots of commands on lots of hosts lots of the time, instead of maintaining the state, which is what you really want those commands to be doing, right?
Yeah, definitely. I'll take a look at that. Yeah, that's a good point.
And even if the machine config operator is not the thing that solves your problem, an approach like that, I think, would be more attractive to me in terms of having something in Metal Cubed. I still do think it's very cloud agnostic, and we might put it in Metal Cubed and tie it to our templates and that sort of thing, but try to build it in a way that it could be used without the rest of Metal Cube, because I could see certainly other people wanting to have access to something like that as well.
Okay, yeah, but it is Metal Cube agnostic. But so, like I said, the idea is pretty general enough that it's not necessarily tied to a provider. It just so happens that we are consumers of Metal Cube, and this was
sure
one of them. But yeah, I can look at the state-based model versus the executor model.
May I ask, like, because you just say that it's agnostic of the provider, but if I recall correctly, in the proposal, you were saying that MetalCube CapM3 would still be doing something, right? Like, so it would like be putting the specific annotations, like doing the link between the template and the actual nodes on the target cluster, right?
Yeah, so what I mean by provider agnostic is that there's nothing, those are operations that any other provider can do as well. You're basically mapping, what you described as you're mapping those machines that were created from a particular template. And you're adding the corresponding Kubernetes nodes that have been created, you're adding annotations to them. That's what CapM3 would be required to do today.
Okay, so meaning that, sorry.
No, go for it.
So I was going to ask, like, so that could be completely separated controller that is just happens to understand the link between the different CRs, right?
Yes, so it could be, but it has to work with. It still needs to understand a Metal3 template, right? If that's where you decide to put this information. It still needs to understand how the mapping happens between a machine template and machines, and how to annotate the appropriate set of nodes that have been created. You could put that in CapM3, or you could create an entirely separate controller that does that. But in the end, it will need to look at the CapM3 objects, right? The CAPI objects. That makes sense.
Okay, Doug, do you have another comment, or is it just the hand is?
I have one
Sorry,
question.
yeah, I just left my hand raised. Sorry.
Dikambar, please go on.
Okay. So about this proposal, because the workload profile and everything, how do you find whether the right workload profile you are getting? Sorry, right node, and how you can attach? Because this profile we need to run with externally, right? It should not be part of core Metal Cube, CAP M3 and others, right? Because this configuration should be separate, and someone should identify where and get you the node which you are going to configure or run the configuration on.
If I understand the question correctly, we do, yes, somebody needs to determine which set of nodes are impacted by a change. And that's where the whole machine deployment idea comes in, is that you've already created top-level objects, cluster API objects, that represent a set of nodes that are impacted. So from a user point of view, if I want to make a change to all my worker nodes, all I have to do is go modify the template that corresponds to those worker nodes. So that's the grouping that's provided by machine deployments or KCP. If
Okay.
I understand the other part of your question, that was more about running the executors. That's entirely up to the user. They can pick and choose what they want to deploy on their workload clusters. So much like you can select CNIs today and install them appropriately. For your networking, idea here would be that you deploy your executors appropriately as well, if you want to use them.
I request you, I think you can look at hardware classification controller. There is one project which is actually finding your right match host, but we are currently only selecting host for ready states and continue it further. But actually entire automation needs to be done for you, because it is only give you the nodes which is in ready state and which are actually uh, workload specifics or fitting for workloads, let's say. And then taking ahead, you need to put those nodes into provisional state so that your labels will be continued further. But I don't still get idea. Let's say before onboarding worker nodes, you still have provisioned images and everything, and there you are going to run a configuration. And if your operator is based on Ansible, so someone has to enable SSH access to you, right?
Yeah, that's implementation details for somebody who implements the Ansible operator. But I can take a look. I'll definitely take a look at the classification control.
Yeah.
Okay, I think we're like starting to reach the top of the hour. So, are there any further questions or comments on this topic? Okay, then let's close the meeting. But before that, just a note that because now we have access to the CNCF resources, we will be able to go back to Zoom with one account coming from the CNCF. We have to contact them and get that in place, but just a heads up that, well, maybe not next meeting, but soon, hopefully, we will like move back to the Zoom setup that is like usual in this kind of projects. Okay, that being said, if there's no like last minute comments or something to add, then I propose we close the meeting.
Thank you.
Yeah, thank you. Bye. Have a nice day.
Thanks.
Thank you.
Bye.
Thank
Bye.
you.
Have a nice day.